In this video lecture, we'll be solving this problem, furthest building you can reach, which is a Leetcode medium problem. In this problem, we're given an integer array heights representing the heights of buildings, some bricks and some ladders. So bricks and ladders are integers. Bricks represents the number of bricks that we have, and ladders represents the number of ladders that we have, which will be used to climb from one building to another, while the heights is an array of length n containing integers. We start our journey from the building number 0 and move on to the next building by possibly using bricks or ladders. Let's see how we do so. So while we move from building number I to building number I plus 1 for 0 based indexing, if the current building's height, that is the height of the ith building, is greater than or equal to the next building's height, in that case we do not need a ladder or bricks to climb the building. We just move to the building I plus 1. Otherwise, if the current building's height is less than the next building's height, in that case we use one ladder or bricks equal to the difference of the heights of the buildings, fine, which is given by hi plus 1, that is the height of the I plus 1th building, minus hi, which is the height of the ith building. So what do we have to do in this problem? We have to return the furthest building index if we consider 0 based indexing that we can reach if we use the given ladders and bricks optimally. So we want to reach the furthest building in this problem, fine. So in the input will be given the heights array of size n containing n integers representing the heights of the buildings, two integers namely bricks and ladders representing the number of bricks and the number of ladders that we have, while in the output we have to return an integer representing the furthest building or the index of the furthest building that we can reach with the given data. Let's see the constraints of the problem. The height array has a length up to 10 raised to the power 5, while each element in the heights array may go up to 10 raised to the power 6. That is, the tallest building may have a height of 10 raised to the power 6, while the maximum number of bricks that we can use may go up to 10 raised to the power 9, while the ladders that we have does not exceed the length of the given heights array. Let's better understand the given problem statement using an example. So here we have our heights array. It has 7 buildings and they are indexed from 0 till 6, and we start from the first building, that is here. So I'm standing here. Now we know that. Now I see the next building, which is building number 1. The index of the next building is 1, and I see if I can jump to that building. And the answer is yes, because the height of the first building is 2, while the height of the building on which I am standing is 4. So I do not have to use bricks or ladders. The number of bricks and ladders that we have in this case are, so we have 5 bricks and the ladders we have are 1. So we have one ladder that we can use. So I jump to building number 1. So here I'm standing at building number 1. I check if I can jump to the next building, that is building number 2. And we cannot jump to the next building. We have to use either bricks or ladder. How many bricks we have to use to jump to building number 2? That is the difference between the heights of this building, which is 7 minus 2, 5. So I can use 5 bricks or one ladder to jump to the next building. So what I would do here, let's use bricks. So I use 5 bricks to move to building number 7. So I jump to building number, so I use my 5 bricks here and they become 0, and I jump to building number 7. Now I'm standing at building number 2 and I see the next building, which is building number, and I check and I observe that the next building is shorter than the building on which I am standing. So I do not need to use bricks or ladders. I just jump to building number 3. So here I'm standing at building number 3 and I see the next building, which is building number 4. And I see that the building number 4 is taller than the building on which I'm standing. So I require either bricks or ladders. How many bricks we require? That is 9 minus 6, which is 3, or one ladder. Do we have 3 bricks to use? And the answer is no, because we have already used our bricks while we jumped from building number 1 to building number 2. So the only option that we have is to use our ladder, our only ladder that we. So I use the ladder and jump to the building number. So here I'm standing at building number 4 and the ladders become 0 as well. Now I ask, can I jump to the building number 5? And the answer is no, because the building number 5 is taller than the building on which I am standing, that is 4, and I do not have either bricks or ladders remaining to jump. So that's the last building which I can reach if I follow the strategy which I followed in this particular case. So what strategy did I follow? I used bricks at the step number 2, that is moving from building number 1 to 2. Here I used bricks, and to jump from building number 3 to 4 I used ladder. If I do the opposite of this, that is use ladder here and bricks here, would that be a better option? Let's see that. Let's say we use ladder here. Fine. So then at this point on building number 3 I do not have any ladder, rather I have my 5 bricks remaining. So standing on building number 3 I ask whether I can jump to building number 4 using bricks or not, and the answer is yes, because the bricks that we require to jump to building number 4 would be 9 minus 6, that is 3, and we have 5 bricks at this point, and hence I can use my 3 bricks to reach at building number 4. So standing at building number 4 I have 2 bricks remaining and 0 ladders. Then I see the next building, which is building number 5, and I ask if I can jump to the building number 5 or not, and the answer is no, because the difference between the heights is 14 minus 9, that is 5, and the bricks that we have are 2, while we do not have any ladder remaining. So even in that case, the farthest that I can go is building number 4. Hence the answer for this test case is 4 in either way. Fine. So that's the answer for this particular test case. Now the question is, how can we devise an optimal strategy to solve this problem such that the algorithm that we come up with must choose only optimal options to arrive at the farthest building, such that the building that we arrive at the end is the farthest building that we can reach. So let's see that. So this is my heights array. We have bricks as 5 and ladder as 1. Let's try to build an optimal strategy to solve this problem. Now here we can see that, observe that the optimal strategy to solve this problem is to start from building number 0 and just keep on moving to the next buildings while using the bricks, as many bricks as we can. Fine. Then at some point, let's say I, when we have exhausted our bricks or we do not have enough bricks to jump from I to I plus 1, in that case I can use ladders. Fine. But in this area where we have used bricks, so I'm sure that in this portion till ith position I have used bricks, and in this step, that is to move from building I to I plus 1, I have to use ladder. So what is the optimal step here? The optimal step is just pick that jump in this portion till I which used the maximum number of bricks. So all I want is to keep track of the step which consumed maximum number of bricks till this index I. If I know that, then I can simply replace that step with ladder. So instead of using bricks there, I can use my ladder. Because doing that, we always have an optimal step, because sitting at position number I have maximum number of bricks remaining, while using my ladder most optimally. I used my ladder in that step which required most number of bricks. So that's the strategy. So the next question is, how would I keep track of the step which consumed maximum number of bricks? For that, I can use a data structure which can keep track of the number of bricks used in a sorted way, so that we can access the maximum number of bricks in the optimal time complexity. And we know that priority queue is such a data structure, because what do we do in a priority queue or a heap? We simply push the items and it gives me item in a sorted order, either increasing order or in decreasing order, so that we can either access the top element in a logarithmic time. So I will use a priority queue to solve this problem, to just keep track of the maximum bricks that I used till index number I or building number I. Fine. So I hope you got the idea. Let's dry run the algorithm which I want to explain here. Okay, so let's try to dry run our algorithm for this test. So we take a priority queue. This is my priority queue. It stores the maximum integer at the top of. Let's start traversing the heights array starting from the second element. So what I do here, I take the difference of the consecutive heights. That is the difference between building number 1 and building number 0. And this difference, let's call it D, is 12 minus 4, which is fine. So I require 8 bricks to jump from building number 0 to building number can I use 8 bricks? And the answer is yes. So I use 8 bricks and I push 8 into the priority. Fine. Then I try to jump to the building number 2, which has a height of 2. I do not require bricks or ladder because the height of building 2 is smaller than the height of building 1. So now I jump to building number 2. Then I check building number 3 and I see that the building number 3 has a height of 7 and it requires 7 minus 2, that is 5 bricks to jump to building 3 or 1 ladder. Do we have 5 bricks? After using 8 bricks, I have remaining bricks as 2. So I cannot use 5 bricks here. So what do we do here? What is the step to take here? So we push this difference into the queue. This difference is 5. Now this priority queue will sort these differences in a decreasing order. So I would have 8 at the top and 5 at the bottom. So what do we check here? So I cannot use bricks to move from building 2 to building 3 because I have remaining 2 bricks only. So what is the optimal strategy here? The optimal strategy here, just check in the priority queue the maximum difference till building number 3. That's what I check. And that difference is 8. Fine. So what do we do here? I optimize the number of bricks which I can use. Instead of using 8 bricks in step number 1, I use a ladder. So I pop this element out of this priority queue and I change the number of bricks to 5. Why 5? Because instead of using bricks in the step number 1, I am using the bricks in step number 3. That is moving from building number 2 to building number 3. So how we move till now? I started from building number 0, jumped to building number 1 using a ladder. So the ladders become 1. Then I jumped to building number 2 without using bricks or ladders. Then I jumped to building number 3 using bricks and I used 5 bricks which gave me 5 remaining bricks. Now I'm standing at building number 3. So that's what I am doing in this algorithm. I'm storing the differences in a priority queue and at any position, at any jump, if I see that the number of bricks that I am requiring for that step are greater than the bricks that we have, then I simply check for the maximum difference till that building which we have encountered. And instead of using bricks for that step, we use ladder there. So I'm optimizing the number of bricks till each building. Fine. So I jump to building number 4 without using bricks or ladder. Then from 4 to 5, from building 4 to 5, I try to jump and the bricks that I require are 15. So I push the bricks that I require into the priority queue. So this is how the priority queue will look like at this, and the bricks becomes 5 minus the difference which is 15, that is minus 10. So since the bricks becomes negative, what does that indicate? It indicates I cannot use the number of bricks to jump from building number 4 to building number 5. In that case, I just return back to 5. How? So I do not need to push 15 here. So I return back to 5. That is, I cannot use bricks in this step. So this is the priority queue which I have till building number. So what do we use here? We use a ladder instead. So the ladders become 0. So till building number 5, I have 0 ladders and 5 bricks remaining. Then I jump to building number 6. The difference between the heights of building 6 and 5 is, so I require 2 bricks or 1 ladder to jump to building 6. Okay, so here I again check if I can optimize the number of bricks, and the answer is no, we cannot optimize the number of bricks here because I do not have any ladder remaining. So I simply use 2 bricks to jump to building number, and the remaining bricks would become 5 minus 2, which is 3. And now I'm standing at building number 6. Then I jump to building number 7 without using any bricks or ladder because the height of 7th building is lesser than the height of 6th building. Then I ask, can I jump to building number 8? And the answer is no, because the difference between the heights is 6, which is beyond our capabilities because we have 3 bricks remaining and 0 ladders, and we did not use 16 bricks in any of the previous pursuit, in any of the previous step that we took, so that I can replace those 16 bricks with a ladder. We do not have any ladder to replace it with either, so we cannot jump to building number 8. So I stand at building numbers at the end. So for this test case, the farthest building which I can reach is building number 7. Hence the answer for the test case is fine. So I hope you got the idea which I explained here. Let's see the implementation of this idea. So this is the furthest building function which takes in the heights array, the number of bricks and the number of ladders that we have initially. I declare a priority queue, initialize a variable I to 0, a difference variable which will be used to store the difference of the heights of the adjacent buildings. I calculate the length of the heights array Then I iterate on the heights array and I take the difference of the adjacent heights. I check if the difference is negative. What does that mean? I do not require, so in this type of case, I do not consume either bricks or ladders. So I continue to the next. Otherwise, I by default consume bricks and push the difference into the priority queue. And here I'm checking if the bricks becomes negative. What does that mean? That means I cannot use the bricks which I by default used here. So I regenerate my original bricks. Fine. So what does that saying? So what I'm saying here, pop those bricks which are maximum in the priority queue, or from that step till this ith index in which we used maximum number of bricks. We simply replace those maximum number of bricks with a ladder. That's why I'm adding the top element of the priority queue till any ith index. Previously in some, let's say jth step, I used very large number of bricks. Let's say those bricks are x because the difference was x between the consecutive heights. While here standing at index number I require some y. So rather than using a ladder here, I will use ladder at jth index because that is more optimal because I'm saving more bricks. That's why I'm doing this. Fine. Then I pop those bricks which are maximum bricks in the priority queue from the priority queue, and I use a ladder instead of those bricks in the previous jth step. And here I'm checking if the ladders become negative. That means I have to break. I can't go further. So I break out of the loop. And finally, I return the index or the position of the farthest building which I can write at the end of the function. So that's how the function is working using a priority queue. Let's see the time and space complexity for the solution explained here. You can see that I'm iterating over the heights array exactly 1, which is linear time complexity, while for each index I'm performing a push or a pop operation for the priority queue, which is a logarithmic operation, while giving me the overall time complexity as n log n. Hence the time complexity is n log n, while the space complexity is linear because I'm using a priority queue. So for storing n integers, I require big of n. That's the time and space complexity. Let's jump into the code implementation. So this is a solution class which contains this furthest building function which takes in the heights array, the number of bricks that we have, and the ladders that we have. So these are two integers. I find the length of the heights array. यार शांत रहो यार थोड़ा चिर 10 कमेंट 5 कमेंट शांत रह लो फिर कर ले. I initialize my index variable which will, so I denotes the index of the furthest building which I can reach. Then I initialize a difference variable with 0. Then I iterate over the heights array starting from the first building till second last building. I find the difference between the adjacent heights, and so I calculate the size of the heights array. I initialize a variable I which will store the index of the furthest building which I can reach, and a difference variable which stores 0. Then I declare a priority queue. This priority queue is used to keep track of the maximum bricks which are used till index number I or building number I. Then I iterate over the heights array starting from the first index till the second last index. So I calculate the difference between the adjacent heights. Then I check if the difference is negative, or then I check if the difference is not positive. It is either 0 or negative. That means we do not require bricks or ladders to move to the next building. So I continue to the next building right from here. Otherwise, I by default use bricks. I try to use bricks and I push the difference into the priority queue, or the bricks that I use into the priority. Then I check if the remaining bricks becomes negative. If the bricks becomes negative, that means I cannot use bricks here. I have to use a ladder at this step. Then I have to investigate whether it is optimal to use the ladder at this step or at a step previous to index number I. For that, I simply extract the bricks extract the maximum bricks which are used, or the maximum difference between the adjacent heights till index number I, which is present at the top of the priority queue. And I pop that element from the priority queue because I'm using ladder for that particular step. And since I'm using ladder, I decrement the number of ladders by 1. In any case, if the ladders becomes negative, that means I have consumed extra ladders. So this is the last building which I can arrive. We cannot move to building number I plus 1. Hence I break right. Finally, I will have my index I, which is the index of the furthest building we can reach. So I return that index. So this is the simple implementation using priority queue for this particular problem in C++ language. Let's see the implementation in other languages as okay. So this is the implementation in Java, and this is the implementation in Python language. So that's all for this video. If you like the video, then hit the like button and make sure to subscribe to my YouTube channel and give your feedback in the comments. I will see you in the next video. Till then, take care. Bye bye.